All of us know how to find the cube of a number. So 3 when cubed gives us 27. It means 3 multiplied by 3 multiplied by 3 equals 27. So what is a cube root? Well, the cube root of 27 is 3. That's all. This is the most important concept of cube roots. The rest of the video will just focus on how cube roots are denoted and its application. So remember, 3 cubed is 27 and cube root of 27 is 3. Well, this is how the symbol of a cube root looks like. A root sign with a 3 here. So we can say that the cube root of 27 is 3. And as we saw in the square root video, this root sign is called the radical. And the number inside it is called the radicand or the base. Here's a better way to understand the concept of cubes. 4 cubed equals 4 times 4 times 4, which equals 64. We all know this. This 3, when taken to the other side, becomes cube root. Hence, we can say that the cube root of 64 equals 4. Now, we're on our way to understand a very interesting concept. We will try to understand this concept with just one example. We know that cube root of 64 is 4. This example looks very simple, but modifying it slightly can make it interesting. Let's play with these numbers. We can write 64 as 2 raised to 6. Hence, cube root of 64 can be written as cube root of 2 raised to 6. We can also write 64 as 4 cubed. Hence, we write this as cube root of 4 cubed. Now let's try writing 4 in an exponential form. 4 can be written as 2 squared. Hence, this would equal 2 squared. And of course, it can also be written as 4 raised to 1. What do we observe? Yes, when we take a cube root of a number in exponential form, the base remains the same and the exponent is divided by 3. 6 became 2 and 3 became 1. Remember, when we take a cube root of a number in exponential form, we should keep the base same and divide the exponent by 3. Let's quickly look at a couple of examples. Say we want to find the cube root of 4 raised to 9. The base actually equals 262,144. Imagine finding the cube root of this big number. But using our technique, all we need to do is keep the base same and divide the exponent by 3. Here the base is 4. Hence we write a 4 here. And divide 9 by 3. Hence we get the cube root of 4 raised to 9 as 4 raised to 3. Now let's try finding the cube root of 7 raised to 6. We can write it as 7 raised to 6 by 3, which equals 7 raised to 2. So remember, keep the base same and divide the exponent by 3. In the coming videos, we will see how we can calculate the cube root of large numbers which are not in exponential form. You will learn how to find cube roots of larger numbers, that is up to 6 digits. Come on, don't worry. And how long do you think you will take to find the cube root of a large number? If you focus hard for the next couple of minutes, you will be able to find the cube roots of large numbers in just 5 seconds. Yes, you heard me right. 5 seconds is all you will take to solve the cube roots of large numbers. Let's see a couple of examples. Assume we want to find the cube root of 2197. Now to get the answer in 5 seconds, there are 2 things you need to know. First, we need to know the cubes of numbers from 1 to 10 by heart. Here's the tables of cubes of numbers from 1 to 10. In the first column, we have the numbers, and in the second column, we have the cubes of those numbers. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and so on. Second, we should know that for 4, 5 and 6 digit numbers, their cube roots will always be 2 digits long. Since 2197 has 4 digits, its cube root will also be 2 digits long. That's it. Only these two things. Cubes of numbers from 1 to 10 and the fact that large numbers which are 4, 5 or 6 digits long will have cube roots which are exactly 2 digits long. So let's move on. Look at this table for a moment and think. Is there anything that stands out? Pause the video and think for a moment. This is what you should have observed. Look at all the units digits of the numbers in the cubes column. They are all different from each other. All numbers from 0 to 9 are covered. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Knowing this fact will help you understand the first step in our method. Okay, now we're all set to go. The first step of our method is to look at the units digit of the number. The units digit of 2197 is 7. So we look at our table. In the cubes column, we look for a number which has its units digit as 7. It's this one, 27. So we take the number from the first column corresponding to it and write it in the units place of the answer. The number corresponding to 27 is 3. So we write 3 here. So the first step directly gave us the units digit of the answer. Remember, the answer is the cube root of 2197. The next step is interesting. We ignore 3 digits from the right of the number. So we ignore 197 for the moment and look at the number that remains. It's 2. This number is very crucial. We check where 2 is placed in the cubes column. That is, we check the position of the remaining numbers in the cubes column. In the cubes column, the number 2 lies between 1 and 8, between these two numbers. That means it is placed between 1 cubed and 2 cubed. We basically looked at the corresponding number column. The last step is very important. Now that we know where it is placed, we choose the lower number in the corresponding number column. The lower of 1 and 2 is 1. That's it. This is your tens digit. So cube root of 2197 is 13. Remember, we always choose numbers from the first column, which is the numbers column, to write the digits of our answer. 3 was chosen from here and 1 was chosen from here. This looks really long at the first look, but with practice, trust me, you'll be able to solve it in 5 seconds. Now let's solve another problem so that you understand better. Say we want to find the cube root of 195112. This number is 6 digits long and hence its cube root will be 2 digits long. Remember, cube roots of large numbers which have 4, 5 or 6 digits will always be 2 digits long. Now let's see the units digit of the number. It's 2. In the cubes column, we look for a number which has its units digit 2. Yes, it's 512. And the corresponding number in the numbers column is 8. So we write a 8 in the units place of the answer. Now we ignore 3 digits from the right, that is 112, and what remains is 195. Now where is 195 placed in the cubes column of the table? It is placed between 125 and 216. That is, it is placed between 5 cubed and 6 cubed. So from the numbers column, we choose the lower number among 5 and 6. It is 5. And we write this number in the tens place of the answer. Hence, the cube root of 195,112 is 58. With good practice, you will be able to solve this in 5 seconds. And remember that this method is a shortcut and cannot be used to solve questions in your exams. You may use this method purely to verify your answers. This video on cubes is very similar to the one on squares. If you've understood the concept of squares, the concept of cubes will be stress-free. Let us get to the basics first. Look at this number on the board. It's read as 7 raised to 3. And raised to 3 is called cubed. So the number can be called 7 cubed. Why do we have a distinct name for raised to 3? Well, it's the same reason as to why we have a distinct name for raised to 2. It's because raised to 3 has many applications. Here is one of the practical examples. Assume we have a box in the shape of a cube. Assume the lengths of all its edges equal 3 centimeters. If we remember correctly, the volume of a cube is given by side multiplied by side multiplied by side. So that will equal 3 multiplied by 3 multiplied by 3. So this is actually 3 cubed. That will give us 27. So that's one of the practical applications of cubed or raised to 3. But wait, are we forgetting something? Yes, it's the units of the answer. So the units of each side are also multiplied to get centimeters cubed. That's the precise answer. The volume of the cube is 27 centimeters cubed. The answer can also be written as 27 cubic centimeters. So we can see that when 3 lengths are multiplied, we utilize the concept of cubes. Let's understand another straightforward example. Solve 10 centimeters multiplied by 9 centimeters multiplied by 6 centimeters. Multiplying the lengths gives us 540. We did not use the concept of cubes here as we have 3 different numbers. But multiplying the units gives us centimeters cubed. So the answer can also be written as 540 cubic centimeters. So whether it's squared or cubed, the units also differ accordingly. Now there's a vital property we need to understand. To understand the property, here are a few examples. How do we find the value of 7 cubed? It is 7 multiplied by 7 multiplied by 7, and that equals 343. Minus 14, the whole cubed, equals minus 14 multiplied by minus 14 multiplied by minus 14. That equals minus 2744. And similarly, 18 cubed equals 18 multiplied by 18 multiplied by 18, which equals 5832. Observe the sign of the number and the sign of the answer. If negative, then negative. If positive, then positive. So we can say that for cubes of numbers, the sign of the answer is same as the sign of the number. That is, cube of a negative number will result in a negative number, and the cube of a positive number will result in a positive number.